Our storage system went from being a limitation to something we don't have to worry about. At Luma AI, we are trying to build multi-modal AGI that is trying to understand and generate things that appear in the physical world, similar to how a human brain would learn. So we're not just trying to limit ourselves to text, videos, or images in isolation. We're trying to build models that can natively understand and generate all of these at the same time. I'm Thomas, and I am leading systems research and engineering at Luma. When you start spinning up these really large collaborative training jobs that span up to thousands of GPUs, and each GPU and each process needs to work in tandem, if any single part of it is not reliable, or if any single part of it fails or is slow, that drags down the whole process. Storage performance, and particularly the flexibility of switching around our experimental environments, is super important for us because we want to run like many different experiments in a day. So we needed a solution that is able to handle the flexibility of switching environments really often, really fast. Before we figured out some of the solutions that we have right now, it was actually really painful to look at our GPUs sitting idle for like 10 or 20 minutes for it to run, start the job, only to then maybe crash with an unrelated error, which could have been found earlier if our iteration times were faster. What caught my eye about neural mesh was just the promise of performance, efficiency, and reliability, which for us, the thing we care about the most. If it's something we can easily deploy and also it fulfills our criteria for efficiency, that is all we need. The business impact of deploying neural mesh has been pretty substantial for us because we were able to use its flexibility and efficiency to ship our products faster. After deploying neural mesh, we observed speed improvements from going from 10 to 20 minutes of starting a job towards 30 to 60 seconds of starting a job. So that's a 40 times speed improvement. Neural mesh gives us a super good trade-off between flexibility and still being able to scale towards larger deployments. So when a researcher is doing their initial experiments, they can easily switch around between things, but just with the click of a button or with one terminal command, they can launch it to hundreds of nodes and it'll still work. Working with neural mesh helps me speed up our experiments and speed up the efficiency of our training deployments.